My name is Macy Gotchel, and this is my video presentation for Experiment 6 about equilibrium, specifically reactions A, E, and F. So for part A of the experiment, we dealt with acetic acid and acetate equilibrium, which is formed by the equation right there, which is CH3COOH aqueous, which is at equilibrium with CH3COO negative aqueous plus H plus aqueous. So in the experiment, we took two pHs. The significance of the first pH measurement is to offer a comparison for the next recorded pH. And then you can see that listed here. Also, the colors of this experiment were clear, clear, and clear, which is why we had to test the pH to see the colors. The pH level of the first one was the pH level of the 0.1 mole acetic acid was roughly 4 to 5, making it acidic. And as you can see on the picture to the side, it is a warm color. And then for the second aspect, when sodium acetate was added to the solution, it had a higher pH level compared to the 0.1 molar acetic acid. So the sodium acetate's pH level was roughly 6 to 7, making it basic or neutral. And as you can see on the picture to the right, it is also a warmer color, but a little more cooler compared to the previous. And adding the sodium acetate increased the pH, thus making it more basic. So part A continued. When we consider Le Chatelier's principles, the whole goal is to reestablish equilibrium in the equation. So for this equation, K is going to shift right because 1 gram of sodium acetate was added to the reactant side, meaning that there are now fewer products compared to the reactants. And so K is going to shift in order to try and balance that out. And this is all because of the stress, which was adding the sodium acetate as a reactant. So as you can see here on the slide, we have addressed the stress and how it's going to shift. There is your equation. The question mark on the slide is actually representing the equilibrium symbol, because in this equation, both sides, the first side and the second side, are at equilibrium with each other, of course. So then, according to Le Chatelier's, the shift to the right is to the right, or also known as to the products, in order to balance, because you need to create more products because the 1 gram of the sodium acetate was added to the reactant side. And so because there are fewer products compared to the reactants, K is going to shift to the right to balance it out. Part E was the second part of the equation, or of the experiment, that we are going to acknowledge. It is represented by the equation on the screen, which is Fa3 plus aqueous plus FCN negative at equilibrium with Fe, aka iron, SCN2 plus, and we had heat as a product. The colors of this experiment, the Fe3 plus is a pale yellow and it's clear. The SCN is also clear, but no coloration. And then the combined SCN2 plus was a orange, but is supposed to be an orange, but in our case was more of a blood red. And then you can see that in these pictures here. A continuation of part E. One thing to note is that when the KSCN was mixed with the FeNO3, it changed into an orangish red blood color, which is what we've already seen. Which is what we've already established, excuse me. And we were unable to see the solution see through the solution until it was diluted with water. Noted there. The second aspect of this experiment was adding heat. When heat was added to the solution, it turned an even darker red, virtually black, and it was a little bit cloudy, so it was even harder to see through than previously stated. However, compared to the rest of the class, which there were some variations that correlated with ours, the reactions were actually supposed to get lighter to show that they were exothermic. But because ours got darker, that meant it was endothermic, which then makes heat a reactant. And this was evident because of the fact that heat was added and the color got darker. Vice versa would happen if it was exothermic, which the color would get lighter, which is what was supposed to happen, but for our case, it did not. So as you can see on this slide, number 5 is roughly the color of what the Fe plus is supposed to be, which is accurate because that is what ours started out with. When we mixed the two components, the expected, according to the first picture that was on the slide, is roughly number 3, but ours actually ended up looking like number 2, which is fine because in the end, we ended up getting variations of color. When we added heat, that color change from number 2 shifted more into color number 1, even though the experiment expected it to become lighter instead of darker. Continuation of part E, we added potassium thiocyanate and iron 3 nitrate. When we added the FeNO3, instead of the reaction that occurred between the solution that was already in the tube, and then we added the FeNO3, it became a slightly more orange color. It was not a very prominent change, however, it was enough to take note of. And then we also added the potassium thiocyanate, of course, and when we added that into the solution of the KSCN and the FeNO3, it became almost a black color, and it was very, very dark. So you could say, obviously it didn't turn completely black because of the color scheme on the previous slide, but it did become a very, very dark red color. That is stated here. The other aspect of this experiment was the precipitate, based off of the equation stated right here on the screen. The precipitate that formed based off of this equation was the 3AgSCN. We know this because it was the solid. When this was produced, it was a whitish color. And then because of the fact that there was a precipitate formed, to reestablish equilibrium, everything would have to shift to the right because the stress is the addition of the AgNO3, which would thus produce the precipitate AgSCN. As you can see on this slide, once again, we're referencing colors. So after we added the FeNO3, it changed from a number 2 and it became closer to a number 3. It became lighter. And then adding the KSCN changed from a number 2 to a number 1. It became almost a black color, possibly very dark. This slide is not addressing when we added the silver nitrate, because obviously on the screen you do not see a whitish precipitate as a result. Referencing experiment, or the part of the experiment, specifically this one, according to Le Chatelier's principle. So as previously stated, our reaction was endothermic, even though it was not supposed to be. And we know that it was endothermic because of the fact that our solution got darker when the heat was added instead of it getting lighter. This makes us aware that heat was a reactant or acted to react in this situation instead of being produced. And then, as I previously stated, exothermic would have been lighter. So based off of this, we know that the reaction will shift right towards the reactants to reestablish the equilibrium. And you can see that on the number line there. The final part of experiment 6 that I will talk about is part F, which was based off of this equation here, which is the HCO3 negative, which is at equilibrium with the CO2 and the hydroxide. During this experiment, the HCO3 is actually a blue, very, very blue reagent that will tell you whether something is basic or acidic based off of the colors that it produces. So in the picture, you can see a blue solution and a yellow solution. The yellow solution represents a very acidic solution, and the blue means that the solution in that beaker is basic. So in the case of the experiment, the HCO3 is blue and the OH is also blue. During the experiment, the flask was hooked up to a vacuum. Excuse me, sorry. In this case, the CO2 would have been removed because of the fact that it was the gas, and the gas is the easiest thing to suck out of the beaker at hand. Not beaker, I'm sorry, flask. So from there, that is the reason that we get a loss of CO2. That's because the pressure was increased and the section was present. Next slide. There we go. So according to Le Chatelier's principle for this specific experiment, as I've stated, during the experiment, the suction affected the CO2 because of the fact that it was a gas, so thus it was removed from the flask. This was actually the stress that occurred. The stress, as stated there we go, was a decrease in the level of CO2. So because of this, the OH, which is the other product, will have to increase in order to keep the equilibrium. Excuse me. This increase actually caused the color change of the solution to be more and more blue because of the fact that OH is a base, and thus the increase in the base would cause a more blue color versus the yellow color. And this was actually stated in our lab manual, that if the pH is greater than 7, it'll cause the solution to be blue because that means that it's basic. And as I've said, it's going to shift to the right to produce more products because of the fact that there was a loss of products during the actual experiment. And there is the Le Chatelier's number line representing the fact that K shifts to the right. Thank you, and that concludes my video presentation.